Assalamualaikum warahmatullahi ta'ala wabarakatuh and have a very good day. Today, I'm going to share my research on Eco-Efficiency Index Framework (EEIF) Guideline for Sustainable Reinforced Concrete Design. Here is my team member consists of me, Muhammad Samsuddin Abdul Hamid, Dr. Siti Hafizan Hassan from Faculty of Civil Engineering UiTM Cawangan Pulau Pinang, and Professor Dr. Nasir Syafiq from Department of Civil and Environmental Engineering, Faculty of Engineering, University Technology, Petronas. Here is my presentation outline, consists of background and problem statement, objective, framework development, Eco-Efficiency Index Framework (EEIF), Eco-Efficiency Index Guideline, novelty, commercialization potential, publication and recognition, and also references. As the background and problem statement, when I was 5 years old in 1990s, the average temperature in Malaysia is only 25 degrees Celsius, but now it is reported in February 2021, the average temperature is become 36 degrees Celsius. What caused this problem? Due to unplanned development and economic activities may cause the increasing of CO2 emission in our atmospheres and also CO2 concentration in our atmospheres. Therefore, United Nations Development Program come up with brilliant idea by introducing sustainable development concept by integrating economic, social and environmental balancing. Recycle is also one of the idea to promote sustainability, but we have to be careful either this recycling concept will give a benefit to our environment or not. In Malaysia, there is a Green Building Index has been introduced by Green Building Index Sendian Berhad to promote sustainability, where we can classify the building that we design in different level of green. Therefore, in Malaysia itself, many researchers come up with the idea by using recycled material as a replacement material in concrete. Some of the idea come out to replace this ordinary Portland cement, which is produced from the natural resources, which is limestone. And one of the idea is using fly ash and also blast furnace slag. This fly ash is come out from the coal electric power plant, and blast furnace slag is come out from the steel production. Then we have to examine this material, either it benefit to the environment or not. Therefore, I do come out in my study by integrating the sustainable development criteria, which is the emission of carbon, and also analyzing the cost of the material that we use in reinforced concrete structure to examine the eco-efficiency index of the building. Here is the objective of this study. The first one is to develop the eco-efficiency sustainable structure design of reinforced concrete structure, and then the second one is to develop eco-efficiency index framework (EEIF) guideline of reinforced concrete structure for promoting sustainable structure design. Here is the process to develop the framework. Consists of the reinforced concrete structural design, taking of material volume of concrete and also steel. Then we come out with the calculation of economical and environmental score, and then involve on the eco-efficiency index analysis. Then come out with the responsiveness model to come up with the prediction model, and last but not least, we may classify the eco-efficiency classification of the building or structure that we design. Here is the eco-efficiency index framework that we can use this framework in order for us to design sustainable reinforced concrete structure. This eco-efficiency index framework is used to design the reinforced concrete sustainable structure. The process involved on structural configuration, material analysis, sustainable analysis, eco-efficiency index analysis, eco-efficiency classification, and also green building index classification. We may use this overall process in order for us to take it as a guideline to perform or produce the reinforced concrete structural design that promoting sustainability. This is the Eco-Efficiency Index Framework Guideline. This guideline is benefit for the structural designer to produce sustainable reinforced concrete structure that fulfill need of the Green Building Index under criteria 6 on innovation. It is also providing the overall design specification for reinforced concrete structure, including analysis of cost and equivalent carbon emission of reinforced concrete structure. Furthermore, this guideline is also providing a selection of the structural element specification for different eco-efficiency level that is important to be used in the design. Let's have a look on the novelty of this research. There is three novelties. The first one is on the formulation, which consists of the emission factors of alternative reinforced concrete, EFRC. Second one is the economical score, and then the third one is the environmental score. These three formulation is used to determine the eco-efficiency index of the reinforced concrete structure. Second one is the prediction model for eco-efficiency index of reinforced concrete structure. This prediction model is able to be used to predict the total amount of the CO2 emission of the reinforced concrete structure, and also to estimate the cost that is meeting the requirement of the different eco-efficiency level. For example, if we would like to have the moderate level of eco-efficiency, we may know how much the CO2 emission and then how much the value of the eco-efficiency index. So this prediction model will help you to analyze those variables. Last but not least is the Eco-Efficiency Reinforced Concrete Structural Design Guideline. This guideline is a new approach on score evaluation for innovation key criteria in GBI rating system, where we can embed this calculation or this analysis in criteria 6 of GBI rating system. As the potential of commercialization, the Eco-Efficiency Index Framework is a guideline, then therefore it is potentially being used as a reference among engineers to design alternative reinforced concrete structure for slab, beam, column and foundation that producing low carbon emission by using alternative material such as fly ash, blast furnace slag to replace natural resources, especially cement, using ordinary Portland cement. Here is some of the publication and recognition that I do receive from this research work. There is a publication in Journal of Applied Science, which is indexed under WAS and also Scopus with Q2, and also some Q3 Scopus journal. And also I do already receive the Gold Award during Index 2020 organized by UITM Perak. Besides that, this product is also registered to get the copyright, which is under topic of Eco-Efficiency Index Framework EIF for Reinforced Concrete Structural Design Guideline. Here is some of the references that I do use in producing this research work. As the way forward, before I end this presentation, I would like to share to all of you one fact. During the pandemic years 2020 to 2021, it was recorded by Global Carbon Budget 2020, there is a reduction of 7% CO2 emission all over the world, which is equal to 2.4 gigaton CO2 emission. And this is recorded as the highest CO2 emission all over the year since the Second World War. This is already trigger my mind where in order for us to make sure and save the earth, we have to control the development and economic activity that may harm the environment. Then that's why I do come out in this research by using the recycled material. People saying that by using the recycled material is good for the environment, but please don't misconcept on the recycling of the material in sustainability. When we go to the detail in the analysis, not all of the waste material will benefit the environment, but some of it may harm the environment. So please be careful. on using the waste material in a new approach in concrete technology or any other application. That's it, my presentation. Thank you.